In Chapter 6, we're going to study the law of sines and the law of cosines. These laws allow us to find angle measurements or side measurements on any triangle. So far, most of the triangles we've studied have been right triangles, and we've used SOHCAHTOA to solve. You can still use SOHCAHTOA when it's not, or when it is a right triangle. The triangles are mostly for us going to be oblique triangles, and an oblique triangle is a triangle that has no right angles, which means it has to be acute or obtuse. Now, something about the angles and sides, if you were to read the book, in all of the problems we're going to be doing, the angles are named with capital letters, and the sides are named with lowercase letters, where side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. That's not told in the problems, it's understood. So over here, in this obtuse triangle, if that's angle A, this is side A. If that's angle B, this is side B. If this is angle C, that's side C. In the law of sines, it tells you that if A, B, and C are the measures of the angles of the triangle, and lowercase a, b, and c are the lengths of the sides opposite these angles, then the law of sines says that if you take the sine of an angle and put it over side A, its ratio is equal to the sine of angle B over side B, which is equal to the ratio of the sine of angle C to side C. This ratio can be flip-flopped. This is usually the way I will write it. You are comparing a side in your ratio to the sine of an angle in your ratio. The side and the angle used are always opposite of each other. The law of sines is used when you have an angle side setup, an angle side angle setup, or a side angle setup. A side angle setup is the same thing as an angle side setup, which, if you remember from geometry, meant you could not write a proof, or you could not prove those triangles were congruent, because this produces what we call the ambiguous case. The ambiguous case means that more than one triangle may be able to be drawn, and it creates some what ifs on what the answers are. Working through these examples, you're going to need a graphing calculator, and you're going to need the calculator set up in degree mode. I try and make my triangles that I drawn to a scale as much as possible, but it's really not that important. We're given in this triangle that angle A is 24.3. That means this is side A. Angle C is 54.6. That means this is side C, which is 2.68, which leaves this as angle B, and this is side B. So we are told to solve the triangle. So when the directions just say solve the triangle, that means you are going to have to find any missing part. For us, that means we're going to have to find side A, angle B, and side B. Those are the missing parts. To do this, we look at the setup. If you look at the setup, this is a side angle setup, which tells us to use the law of sines. To find angle B, we're just going to use good old geometry, and we know that triangles add up to 180, so we're going to subtract the two given angles from 180, and we're going to get angle B to be 101.1 degrees. The directions say round to the nearest degree, but if I did that, it would not add up to 180 degrees. So my rule of thumb is always round to how the problem's presented. So both the angles that were given were rounded to the nearest tenth, so that's how I'm going to write my answer. Now if I go to find side A, the law of sines says that a side over the sine of the angle opposite it is equal to another side, the only other side I know is side C, over the sine of the angle that's opposite it. The angles always go with the sines. Now to solve this, I'm going to cross multiply. And as you get better at this, you can do this cross multiplication on your calculator. I'm going to get A times the sine of 54.6 equals 2.68 times the sine of 24.3. Then I divide both sides by the sine of 54.6. I'm going to make sure that my calculator is in degree mode. And I'm going to type this in all at once, 2.68 times the sine of 24.3. It will look like this on my calculator, divided by the sine of 54.6, and I get A to equal 1.35. Now I'm going to have to find side B. Got to give myself a little bit more room here. So to find side B, I'm going to take B and put it over the sine of B, which was 101.1, and set it equal to another side. I'm just going to use the given side, 2.68 over the sine of 54.6. Cross multiply again, and we're going to get B times the sine of 54.6 equals 2.68 times the sine of 101.1. And then we divide both sides by the sine of 54.6. And we get side B to equal 3.23. Remember, all triangles have 3 sides and 3 angles. So when you're done, you have to make sure you have 6 total parts. 3 were given and 3 we found. Now we're going to work through some story problems. Draw a picture. A guy wire to the top of the tower makes an angle of 54 degrees with the ground. So you have your tower, and then the wire makes an angle that's 54 degrees with the ground. So here's my 54 degrees. At a point 29 feet farther from the base of the tower. So I'm standing here right now, and I have to go 29 feet, 29 feet farther from the base of the tower. So that distance is from there to there only. And in line with the base of the wire, the angle of elevation, so I'm looking up, to the top of the tower is 25. What is the length of the wire? Well, remember my wire was back over here. So now what I'm going to do to find X is I have to realize that I need to use the red triangle, which is the triangle on the right, and I'm going to have to find some missing parts. I know that a 54 degree angle and this angle right here form 180 because they're supplementary. So if I take 180 minus 54, I get 126. And then my red triangle adds up to 180. So 126 plus 25, if I add those together and subtract from 180, I get this angle up here to be 29. And that 29 degree angle is opposite the 29 side length. The 25 degree angle is opposite the X. So now I'm going to take X over the sine of the angle that's opposite it, which is 25, equals 29, which is the side, over the sine of the angle 29. Cross multiply, and you should get X equals 25.28, and this is feet because it's a story problem. Example 3 has a ship sailing parallel to shore. So here's my shore. And it sights a lighthouse on the shore. I'm going to draw a stellar lighthouse here, guys. Looks like an Olympic torch or a tree. So the ship is sailing in the water that's parallel to the shore. So my ship is, we're going to say, over here somewhere. Going to be a pretty good ship too. My ship is sailing parallel to shore, and 11 degrees is pretty small, so that ship's pretty far away. And it sights the lighthouse, so we're looking up at the lighthouse. And this angle, remember your angles are always formed with a horizontal, is 11 degrees. After traveling 3 miles farther, the angle is 25 degrees. Well, 25 isn't much bigger than 11, so this ship did not travel very far at all. It traveled 3 miles, which is maybe puts us right there. So here's your 11 degrees up to the lighthouse. And now the angle of elevation to the lighthouse is 25 degrees. What you got to think about is that when your ship is right here, at the second location, it's looking in this direction. So the angle that's 25 degrees is actually outside that red triangle. And I'm going to erase the top of my, whoa, I erased a little too much there, sorry. Okay. At that time, so at this time right here at the second sighting for the ship, how far is the ship from the lighthouse? So we want to know this distance. Well, if you think about it, we always have a triangle. This angle and the 25-degree angle form 180. So 180 minus 25 is 155. 155, 11 add up to 166. So when you subtract that from 180, the angle up there by the lighthouse is 14 degrees. So now I can use the law of sines, and I'm going to take the side, which is 3, and put it over the sine of 14. Set that equal to x, which is the side I'm looking for, over the sine of 11. Cross multiply and solve. You guys can do that math, and you get x to be approximately 2.37 miles. When you're working through these problems, a quick check for you is to always make sure that the smallest angle is opposite the smallest side. Your smallest angle was 11. Your smallest side we just found is 2.37. The second smallest angle is 14, and it's opposite of 3. Well, 3 is bigger than 2.37, so our answer makes sense. On the next example, an airplane is sighted at the same time by 2 ground observers. So here's my airplane, and here's the ground. So this airplane is spotted by a ground observer right here. Give him some arms. And a ground observer over here. These ground observers are 3 miles apart. So this guy's looking up to the plane, and this guy's looking up to the plane. So in this particular problem, if I connect their eyeballs, this distance right here is still 3 because those lines are parallel. They report angles of elevation as 10 degrees and 23 degrees. Well, if I extend this out here, because this is the direction that this guy's looking, the 23-degree angle has to be closer to the airplane because it's bigger. And the 10-degree angle has to be farther away from the airplane. We want to know how high the airplane is. Well, height from geometry forms a perpendicular with the side or an extension of the side. So to find the answer, which is actually H, we're going to have to do this problem in 2 parts. We're going to have to use this triangle first, which has a 23-degree angle on the outside, so 180 minus 23 is 157. 157 plus this 10-degree angle is 167. If I subtract that from 180, I get this side to be 13. I know that 3 is opposite of 13, So I'm going to do 3 over the sine of 13 equals x, because it's the shared side of both triangles, over the sine of 10. If I cross multiply and find x first, which is 2.3158, I want to take that out 4 decimal places because that's not my final answer. Then I can go back and find h. H is opposite of the 23, so I'm going to do h over the sine of 23 equals x, which is 2.3158 over the sine of 90. The law of sines can be used in any triangle. So even though the height is forming a right angle and the side h is in a right triangle, I can still use the law of sines, or I could have gone back and used SOHCAHTOA to find h. When I cross multiply here, I'm going to get h equals 0.9048 miles. Now that brings us to the ambiguous case. The ambiguous case is covered down here in this blue box, and it only happens when you have a side-side angle set up in your triangle. The ambiguous case produces sometimes just one set of answers, like we've been getting. Sometimes it will produce a right triangle with one set of answers, like we've been getting. Sometimes the given information may produce a side that's too short and doesn't touch the other side, so no triangle exists at all. And then the other times, and these are the ones that are harder to figure out, are when there are two sets of angles, because two triangles could exist with the given information. If you look at these next 3 examples, you can see that 2 sides and 1 angle are given. When we draw the triangle, you're going to see that it's an angle side-side or a side-side angle setup. So you're not going to know going into this that you might have 1 set of answers, 2 set of answers, or maybe you can't draw a triangle at all. So you're just going to have to start the problem, start the process. So if I look at this first picture, this first given, I am given a 58-degree angle. I always set up my problems the same way for angle side-side. I always put the given angle in the lower left-hand corner. And then I know, I'm going to draw this a little bit bigger so I can make my picture a little better. Side A, which is 11.4, has to be opposite that. The third piece of information given is always going to be a side, and I will always make that my left side. Since that's side B in my picture, that has to be angle B. But when you're doing the problems in your homework, that might be angle C, it might be angle X. So the letters don't matter as long as the sides are opposite the angles that are given. So now I need to solve the triangle. Those directions mean find all the missing parts. So I need to find angle C, and then I need to find side C. So I'm going to go about that just like I did the other problems in this packet, and I'm going to put 11.4 over the sine of 58 and set it equal to 12.8 over the sine of B. Now this is the first time we've had to find an angle. So when you cross multiply, you're going to have 11.4 times the sine of B equals 12.8 times the sine of 58, and we're going to divide both sides by 11.4. And that's going to give you the sine of B. So the sine of B equals 0.9522. Now remember, to find the actual angle, you're going to do the inverse sine of 0.9522. And we get B to equal 72. I'm going to round to the nearest degree, so 72 degrees. So that's angle B. I'm going to write that in. And then to find angle C, I'm going to use geometry. And I'm going to take 180 minus 58 minus 72, and I get 50 degrees. Now I need to find side C, and to find side C, I'm going to take side C over the sine of 50 equals 11.4 over the sine of 58. And I cross multiply and I get side C to be 10.3. So that's my first set of answers. I never write in the angle at the top or the side at the bottom, because now I have to check for a second triangle. So this was my first triangle and I got answers. Now I have to check to see if a second triangle exists. So what I'm going to do, if a second triangle exists, and hopefully your geometry teacher showed you this, is you're going to take the side that's opposite your given angle. So in my picture, my given angle is 58, so I'm going to take the side that's opposite the given angle, and I'm going to swing it, in geometry, this is how you made a construction, over to hit that part of the bottom line. If I connect those dots right there, then this side is also 11.4, and this triangle is isosceles. What I just did is I created a new angle C, and I created a new side C because I created a new triangle with my given information. This triangle in red has a 58-degree angle, an 11.4 side, and a 12.8 side, and that was my given information. So now I'm going to use that triangle, and I'm going to have to try and find my missing parts. Well, this angle right here, I'm going to call angle B prime. I'm going to call this angle up here C prime, just to show it's different from the other angle C. And I'm going to let this side be side C prime. So to find angle B, we're just going to use geometry. The purple triangle on the right is an isosceles triangle. So if this base angle is 72, then this base angle is 72, because the base angles of an isosceles triangle are congruent. So now to find B prime, you're going to do 180 minus 72. So that gives us 108. To find angle C prime, we're going to do 180 minus 108 minus 58. If you get an answer here, you can have another triangle, and that ends up being 14 degrees. So angle C prime is 14 degrees, which means we have a second triangle. If you get an answer there that's negative, then you can't draw a second triangle. So the last thing for us to find is side C prime, and that's opposite of the 14-degree angle. And we're going to set that equal to 11.4, which was given, over the sine of 58, which was given. We're going to cross multiply and solve, and we get C prime to equal 3.3. Now here's another thing to remember. Your biggest side should be opposite your biggest angle. Our biggest side in the red triangle above is 12.8, and it's opposite angle B prime, which is 108. Our smallest side is C prime, or 3.3, and it's opposite of angle C prime, which is 14 degrees. So it all works out. If we go up here to example 6, in example 6, we're going to start out the same way. We're going to draw a 110-degree angle. Again, I always put my given angle, it doesn't matter if it's A, B, or C, in the lower left-hand corner. Since that's angle A, side A has to go opposite it. Then I take my other side and I always put it on the left side of my picture. Since that's side B, this is angle B, which means this is side C and this is angle C. Here's the problem I see with this right off the bat. In this particular problem, my biggest side is 200 units. My biggest angle is 110. In an obtuse triangle, you can only have one obtuse angle. Well, the 125 is opposite of the biggest angle. That's not right. the biggest angle should be opposite the biggest side. Since 125 is less than 200, that tells us that no triangle exists. This problem doesn't make sense. Now, you're not always going to recognize that. So if you started the setup of 125 over the sine of 110 and set it equal to 200 over the sine of b, you're going to get an error message on your calculator. So when you get an error message, that also is your indicator that no triangle exists. All right, last example. In this particular problem, we have another 110 degree angle. That's going to go on the left side. That's angle A. Side A is 125. Side B, or whatever side is given third, always goes on the left. So this is angle B, angle C, and side C. Now in this problem, we can go ahead and work through the math because the biggest side given is opposite the biggest angle. So I'm going to do 125 over the sine of 110 equals 100 over the sine of B. I'm going to cross multiply. I'm going to take the inverse sign, and I'm going to get angle B to equal 49 degrees. You guys can do that math. If you need help with that, make sure you ask questions. Then angle C, I'm going to get by taking 180 minus 110 minus 49, and that ends up being 21 degrees. So angle C is 21 degrees. And then side C over the sine of 21 equals 125 over the sine of 110. When I work out that math and cross multiply, I get side C to equal 48.2, which I could have just said 48. They didn't tell me what to round to, so I'm going to just pick in this case. In this particular problem, I only have one set of answers. Here's how I know. If your given angle is obtuse, in an obtuse triangle, you can only have one angle that's obtuse. So there's no way to redraw this triangle to make a second triangle. The only time you can have a second triangle and a second set of answers is if your given angle is acute. Make sure you get help on these problems, and the next class, we're spending another whole day on mainly the ambiguous case. Good luck, and make sure you do your homework.